This presentation discusses the results of the SDS page gel, which was the final step in the NGH purification process. Since this was the last step, we had the final say in which fractions to be pulled as we received the most detailed results. Here you can see the results of the SDS page gel, where it is apparent that fractions 21 through 23 contain the NGH protein, as they are the Kumasi-stained proteins of similar molecular weight as the authentic NGH sample. It is also known that these fractions are pure since there are no other bands visible in the lane that would indicate the presence of other proteins. This shows that these fractions would be the best ones to pull. Fraction 3 shows some staining in its lane. However, we believe that to be spillover from the NGH protein lane since the marking is faint and does not fill up the entire well. Fraction 20 also shows faint marking, which could be due to low yield of the protein. However, since it is faint, we do not recommend pulling it.
So how could we improve this for further experimentation? We want to increase yield, which can be done by culturing more bacteria in the overexpression step, or increase the amount of PMSF use. Adding more bacteria in the overexpression step would increase the initial amount of MGH be purified so that we have more in the end result. Another way to increase yield to improve this purification, if protein degradation was problematic, would be to increase the amount of PMSF use. PMSF is a serine protease inhibitor, so would decrease degradation. If this degradation was selective for the region surrounding the his tag, these proteins would not bind to the column and would elute in the early fractions. Of the fractions we tested, we would recommend pulling 21, 22, and 23. These contain our MGH protein and are pure since we only see one band on our gel. This is comparable in size to the authentic MGH sample, which indicates a high purity of the fraction we are pulling. Ways to improve our results would be increase the initial amount of protein by culturing more bacteria during the overexpression step and using more PMSF to reduce or elude protease activity.